In this lesson, we're going to talk about linear regression. And you can see here that I have my Desmos calculator up. We'll be using that throughout this lesson today. So let's talk about what linear regression is. Anytime you're talking about linear regression, you're talking about a scatter plot. And a scatter plot shows the relationship between two variables. And it's represented graphically in the examples below. It's basically a bunch of data points or dots on a graph. And what we're going to be creating today is a line that is going to pass through the data. We call this a line of best fit. This line is also called a trend line. And what it is it's a line that actually generates an equation indicating the general course of tendency of the data. And it's used to make predictions for data that hasn't happened yet. So the line that we're going to be looking at today is an equation of the line, which is why it fits into this unit of linear equations. Now, there are three different types of linear regression, or just regression in general. One is called a positive correlation. You can see why we call it a positive correlation, because it has that positive looking slope. And then we have one that's called a negative correlation that has that negative slope. And then we also have something called no correlation, which means that it's neither positive nor negative. And it's represented in the picture that you see here. And one thing to know about this line of best fit is that the line doesn't actually touch all of the data points. Sometimes it'll touch some of the points, but the idea is that it generally just passes through those points and is kind of gathering the average distance away from all those points. So it's the line that best fits the data. Okay, I do have some instructions here for you in the notes to show you how to determine the equation for linear regression on Desmos, and I'll be showing you that here today as well. Okay, let's go ahead and before we get into Desmos, I do want to talk about these examples right here. And these examples are just asking you to determine what you think the trend line or that regression equation would be for these two examples. So you see this first one, you see that you have all these data points, and we want to figure out which one of these equations best fits that data. Well, I know that I can actually eliminate two of these right off the bat before we even start. And you're probably thinking, well, I can get rid of B and I can get rid of D, because both of those equations have a negative slope. And this is not a negative correlation here. So those two are eliminated. Now I want to figure out, is it A or C? Well, think about the slope of the line. If I were to actually graph this line right here, y equals 4x, well, I could graph that starting at my origin. I'm just going to go ahead and draw a little sketch here. My rise would be 4 and my run would be 1, giving me a coordinate up here. And I could do the same thing in the other direction. So you can see that that would give me a trend line that looks like that, which definitely does not seem reasonable for this data. So I'm going to go ahead and cross that out. Let's go ahead and erase that one, and I'm going to show you the correct one. Y equals 1/4 x. My y-intercept is 0 in this line, so I'm going to go ahead and plot that. And then my slope is 1/4, so 1/4. And then if I go in the other direction, 1/4. And you can see that this line right here definitely represents this data much, much better. So this would probably be the equation of the trend line for this particular set of data. Okay, let's go ahead and look at the second one. So the second one, you're probably thinking, well, I can eliminate two right off the bat here, and they're the two with the slope that's positive. So I'm going to go ahead and just eliminate those. I have A and I have B. I can get rid of those right off the bat. And I'm going to go ahead and take a look at C first. Let's take a look at C. My y-intercept is -1, so I'm going to go ahead and plot him here. And my slope is -3/4. So that's 1, 2, 3, 1, 2, 3, 4. That leads me to right about there. And then I'll go 1, 2, 3, 1, 2, 3, 4, right about there. And you can see that this equation looks pretty good right through that data. Now, let's just go ahead and check the other one just to be sure. I'm pretty confident that C is correct, but let's just look at the other one for fun. Y equals -4/3 x minus 1. Well, there's my y-intercept, and this time I'm going to go down 4. So 1, 2, 3, 4, 1, 2, 3. You can already see it's a little bit off. And then the other direction, 1, 2, 3, 4, 1, 2, 3. You can see that this line is slightly off of the data, and I do think that the other line is a better option for this set of data. Okay, so that's kind of how a trend line works. Now let's go ahead and calculate the regression equation for some examples. Okay. The data in the table below shows the number of passengers and number of suitcases on various airplanes. So you can see we have a table of values that represent the number of passengers and the number of suitcases that are present with that many passengers. We want to find the equation of the line of best fit, and then we want to estimate the number of suitcases on a flight carrying 250 people. So that's where the estimation is going to come in. But let's first go ahead and create our line of best fit. I'm going to go ahead over here to Desmos, and I'm going to open up a new little tab, and I have to actually put these data points into Desmos. So I'm going to go to this little add item plus sign, and I'm going to choose table of values. And this is kind of the tedious part where you actually have to type in all of these numbers. So I'm going to go ahead and put all of my passengers under X, and then I'm going to put my suitcase in under Y. So let's go ahead and put all of those passengers in there. So I'm going to go ahead and just start typing in all of those X values. And you can just put one in and then press enter. And that'll take you down to the next box. And anytime I put data into Desmos, I always just like to kind of take another peek at it again, just to make sure everything is in there properly. Because if one number is incorrect, that's going to affect your actual equation and your answer. So I'm going to jump over to Y1. I'm going to go ahead and put all those suitcases in there. So go ahead and take a moment and do that. Okay, now that all the data's in, again, I'm just going to kind of skim through it really quickly just to make sure everything is accurate and all those numbers are done. And now that my data's in there, I'm going to go ahead and drop down to another little box right below here. And this is where on the first page of the notes here, I gave you a little general idea of what to type into Desmos, but here's what you're going to type in. We're going to type in a Y, and then I'm going to type in a little 1. And then I'm going to use this little tilde thing, and it's up in the top left-hand corner of your keyboard. And you might need to press Shift tilde to get that there. And then I'm going to type in AX1. You can see the line already starting to generate, and plus B. And you can see it looks like it's in the format of Y equals MX plus B. Except the M is now an A, and that's just kind of the syntax that Desmos uses. So what you can see here is some information below that equation, and what we're going to be using are the items at the bottom under parameters. You see how it says parameters A equals and B equals? Those are going to represent your A and B in this equation. So A is representing your slope, and B is representing your y-intercept. And you can actually use all of those numbers there, or you can round your numbers. It's your choice. For this one, for the sake of simplicity, we're going to actually round this to the nearest tenths place, which is actually going to round up to the nearest whole number. So let's go ahead and round this first equation to the tenths place. So I'm going to go ahead and write Y is equal to, if I round that first one to the tenths place, it's going to round it up to 2, so 2x. And if I round my y-intercept to the tenths place, that's going to round me up to a whole number of 8. So this is my equation of my line of best fit. And you don't always round to the tenths. You can truly round to whatever number you want. But for this example, I wanted to round to the tenths. So now that I have my line of best fit, this is the line that is going to be passing through the data. Now, if you really want to, you can actually go and see it on your Desmos over here. You might need to scroll out quite a bit. I think I need to scroll way, way out. See the data? Yeah, there's the data points, and you can actually drag your graph so you can see it a little better. But you can see that this is going to represent the trend line that's going to pass through those points. So it's kind of cool to see that. And you can zoom in on the data if you want. Notice that the line does not actually pass through each point, just some of the points. Now, let's go ahead and use this line to predict a point that's later on. It's a point that's not in our data set. It says here, estimate the number of suitcases on a flight carrying 250 people. Do you notice how in the passengers row we don't have 250 people? Well, we're saying if this trend continues, then how many suitcases should be on the flights? Well, let's go ahead and use our equation here to predict that. So here our equation, well, first of all, we see that 250 people, remember that this represents the passengers, and the passengers represent X. So we're going to actually substitute 250 into the variable X and then solve for Y. So here we go. Y equals 2 times 250 plus 8. And I'm just going to go ahead and simplify that down. So 500 plus 8, that's easy. Y equals 508. And it's going to be 508 suitcases. Now, think about this and ask yourself, does this seem reasonable? Think about the data up here. If I had 250 as my next data point, does it seem reasonable that the number of suitcases would be about 508? Absolutely. If the data is linear, which this is, you should see that as your X increases, your Y is going to increase at that same rate. Okay, so that's showing you that first example. I want to show you another example that is going to look slightly different. So let's go ahead and go to the example 2. I'm going to go over to Desmos and just hit those little X's, and that'll actually X me out of everything because I'm going to start a new graph. You could also press this little button over here that says home, and it'll kind of square up your coordinate plane. So let's look at this one. The data in the table below shows the average price of a ticket at the movie theater. Find the equation of the line of best fit, and then we want to estimate in what year will the average price of a movie ticket reach $17. You can see that that information is not in our data here. So we're going to use our line to project what that should be if the trend continues. So let's jump over to Desmos and let's create a table of values to enter our data. And I'm going to go ahead and put all my years in. And sometimes I love Desmos because once you start a pattern, and if it continues in that pattern, it actually pops up for you. So you have to do like a little less work. But then again, for the price column, those numbers are all going to change. So you'll actually have to put those in manually. So go ahead and take a moment and do that. And be very careful with money because money, you're rounding to the nearest cent, so it's easy to put in the wrong number at any given time. So I personally would go back and just double check and make sure all those numbers are accurate so that your line of best fit is accurate as well. Okay, let's go ahead and generate our line. So I'm going to say Y1 tilde AX1 plus B. And you can see that it generated our parameters over at the bottom here. And it looks like our A is a little less than 1. And our B, look at that B, negative 367.952. Let's go ahead and round this one. I think this one would be good to round to the nearest 100th place, just for the purposes of this example. So let's go ahead and write our equation of the line of best fit. So, whoops. Let me go ahead and grab my pen. Y equals, it looks like if I rounded this to the hundredths, that my A would be 0.19 times X. And then it looks like it would be negative 367.95. And again, you can round to whatever you like. I just decided to round to the hundredths place. The more digits that you actually put down, the more accurate and the more close to the actual like data point itself you'll get. But this is fine for the purposes of what we're doing. All right, now that we've got our equation, let's think about this prediction, okay? Actually, no, before we even do that, I wanna go ahead and look at the actual line itself. I might need to zoom out a little bit. Holy moly, there it is. There's the data. Find the data. Might have to zoom in and out. There it is. Okay, so there's our nice data. You can see our trend line went right through it. And by doing this bottom portion here, you actually calculated that line of regression. So that's why it shows up there as well. Okay, now let's go ahead and estimate. In what year will the average price of a movie ticket reach $17? This time, we're actually looking for X. In the last problem, we were looking for Y. This time, we're looking for what year. So I'm going to substitute $17 in for Y this time. So you have to be very careful about which variable we're talking about. So let's go ahead and we're solving for X this time. All right, so let's go ahead and add $367.95. And you can use your Desmos calculator since you have it open. You can go ahead and actually do this. So I'm going to take 17 and I'm just going to add it to that number. And I get this number, 384.95. And that's going to be equal to 0.19x, and I'm going to divide both sides by 0.19. All right, and it looks like my answer here will be x is equal to 2000, and we'll say 26 because I see that it's 0.05, and we'll just round that down to 2026. So what this is saying is that if this trend continued and we were to get to 2026, the cost of a movie ticket would be about $17 if it continues in that trend. Now we know that trends don't always continue, you know, in that linear pattern, but if it did, by 2026, you'd be paying $17 to get into the movies. So, all right, well, hopefully that was a good explanation of linear regression. That does bring us to the end of our lesson at this time.